In section 7.2, we're going to look at graphing using intercepts. Okay, I do want to kind of remind you of a couple of things. First of all, we're talking very specifically about linear functions in this particular section. Okay, so when it comes to graphing a function using intercepts, this is sort of, I don't want to say sort of, this is exclusive to lines. Okay, so generally any kind of equation in two variables is going to have some kind of intercept. Okay, but you can't use the intercepts alone to graph those functions. Okay, you would need other points to get the true shape of a graph. Okay, now when it comes to linear equations in two variables, they're so simple, they just create a line. And what we need is at least 2 points to draw a line. Okay, as long as you have 2 points on the line, you can get a general idea of what that graph is. Now, I will tell you, more points means a more accurate line, but minimum 2 points to get a line. So we can use intercepts to graph. So please know that this is pretty exclusive to just linear equations or linear functions in two variables, okay? So don't think this is a method that can be spread out across other types of graphs, okay? Now, steps to graph using the intercepts. First of all, you have to determine what the x and the y intercepts are. So we're going to do like we did in example 2, where we're going to take the equation and we're going to find those intercepts. So just as a reminder, to find the intercepts for the x-intercept, we let y equal 0, and then we solve for x. For the y-intercept, we let x equal 0, and we solve for y. And then remember, this is kind of a big deal. You want to write your two intercepts as two distinct ordered pairs, okay? So write intercepts as two distinct ordered pairs. Okay, so that is the process that we talked about in the previous video for determining the x and the y intercepts. Okay, we then plot both intercepts. So this is kind of like a play on the point plotting method. It's just we're kind of zooming into like the really important information and sort of tossing the rest. So we determine the x and y intercepts, we plot those 2 points, and then we connect those 2 points with a line. Please include your arrows on that line. Okay, that's a very personal pet peeve of mine. Okay, so for example 3, it says graph each equation using intercepts. Okay, so for part A, we have 4x minus 3y equals 12. Let's first just find our intercepts. Okay, so for the x-intercept, remember, we let y equal 0 and we solve for x. So we get 4x minus 3 times y, which is 0, equals 12. Well, 3 times 0 is just 0, and then 4x minus 0 is 4x. So we get 4x equals 12. We need to undo the multiplication of 4 and x, so we divide both sides by 4. 4 divided by 4 is 1, leaving you with just x. And then 12 divided by 4 is 3. So my x-intercept is, the x-coordinate is 3, and then we set the y-coordinate to be 0. Okay, now we want to redo that whole process, but this time we're going to find the y-intercept. So this time we let x equal 0 and we solve for y. So we get 4 times x, but x is 0, minus 3y equals 12. Well, 4 times 0 is 0, and then 0 minus 3y is negative 3y. All right, negative 3 times y equals 12 now, so we want to undo the multiplication of negative 3 and y. So we divide both sides by negative 3. On the left, negative 3 divided by itself is 1. 1 times y is just y. And then 12 divided by negative 3 is negative 4. Okay, so as an ordered pair, we said, hey, x is 0, and then we found that when x is 0, y has to be negative 4. So we have our intercepts here and here. So we've done step 1. We determined what the x and the y intercepts were. Now for step 2, we essentially just do the point plotting method just with 2 ordered pairs instead of like 5. Okay, so we want to plot these 2 ordered pairs. So on the x-axis, we have the ordered pair, 3, 0. So at the origin, I go to the right 3, and then I do not go up or down. Now I want to plot the y-intercept. So on the y-axis, I have the point negative 4. But from the origin to get there, I would not go left or right. I would just go down 1, 2, 3, 4. And there we have our graph. Okay, now just as a quick reminder, I want to remind you how you can use Desmos. I do not want you using Desmos as like the student. I don't want Desmos to be doing all of the work for you, but you can certainly use Desmos as a tool to check yourself. Okay, so if you go to Desmos, let me switch my share screen. Okay, that's my calculator. Okay, if we go to Desmos, we had actually, let me remind myself what the equation was. I don't remember right off the top of my head. 4x minus 3y is 12. Now let's go to Desmos. All right, so we want to type in 4x minus 3y equals 12. Oh, I was like, what? There we go. So 4x minus 3y is 12. You can see here our x-intercept is 3, 0. Our y-intercept is 0, negative 4. We can see that this looks pretty close to what we graphed. Remember, if you want to pull up a table of values, that's really easy to do. You type in your equation, and then above where you type in your equations, we have that like little settings cog. So click that, and oh, is it not going to let me do it? Oh, well, it's not giving me the option. Whoops, I didn't mean to undo that. 4x minus 3y equals 12. And then we're supposed to be able to, oh, it's not giving me the table feature. I don't know what I've done. I may have to log in or something. But anyway, you could see that we got the x and the y-intercept correctly. Okay, so let's go back to our worksheet and I'll figure out what the heck is going on with Desmos when I stop this video. Okay, so there we have it. We've got our x-intercept of 3, 0, and our y-intercept of 0, negative 4. Okay, now for part, this should say part B, y'all. Please forgive me. That should say part B, okay? And we have 2x plus y equals 0. So we want to find the x and the y-intercept. So let's start with the x-intercept. So for the x-intercept, we let y equal 0 and we solve for x. So we get 2x plus y, which is just 0, equals 0. Well, 2x plus 0 is just 2x. 2x equals 0. We need to undo the multiplication of 2 and x. So we divide both sides by 2. 2 divided by 2 is 1, leaving me with just an x. And then 0 divided by 2 is 0. So we get the origin. And remember from the previous video, we had that weird situation where the x and y-intercept both ended up being the origin. We're going to have that situation here, but let's just play it out and see what happens. Okay? Now, for the y-intercept, we would let x equal 0 and we solve for y. Whoops, I don't need to write that out. I just need to do it. So we get 2 times x, which is 0, plus y equals 0. Well, 2 times 0 is 0. 0 plus y is y. So we get y equals 0. So we let x equal 0. We found that y had to be 0. Both points are the origin. Okay, so I know that this is a point on my graph, but I don't know where my graph goes from here. Does it go up to the right? Does it go up to the left? Where is my line? So in a situation like this, we must find another point. Okay? We have no idea where this line is going. Does it go way steep like this? Does it go like this? Does it go like this? We have no idea where this line is going. So we have to have a second point to tell us which direction to go. Okay? So if you find yourself in a situation such as this, you have to find another point. So the question is, what point? It can be anything. Okay? So we can let x equal anything, okay? So for fun, let's say we let x equal, I don't know, 3. I pulled that out of thin air. You could let x be anything. So if we let x equal 3, then we get 2 times x, which is 3, plus y equals 0, okay? 2 times 3 is 6. 6 plus y equals 0. I want to solve for y, so I would need to subtract 6 from both sides. Well, 6 minus 6 is 0. 0 plus y is y. And then 0 minus 6 is negative 6. So we get the ordered pair 3. I arbitrarily picked 3. And if x is 3, y has to be negative 6. So now we have 2 points that we can graph. We already know we can graph the origin. We had to come up with some other point to figure out where this line is going. We know it goes through the origin, but in which direction, okay? So I want to plot 3, negative 6. So from the origin, I'm going to go to the right. 1, 2, 3, and then down 1, 2, 3, 4, 5, 6. And I can now connect these 2 points and say that's a pretty good sketch of the line. Okay, now, oh, I know what was going on in my Desmos. I didn't solve it for y. Okay, so when we go over to Desmos, we have 2x plus y equals 0. All right, so we had, whoops. 2x plus y equals 0. That looks pretty close to what we had before. We have the ordered pair 0, 0. That's the origin. And then if I can solve this equation for y, that's what I completely forgot to do earlier for part A. If I can solve this equation here for y and type it in as y equals, I can get it to pull up the table of values. So to solve this equation for y, I would want to subtract 2x from both sides. Okay, so I'm going to rewrite this one or retype this one as y equals negative 2x. Whoops, I'm not even typing it. Y equals negative 2x. You don't really have to put the plus 0, but just know if you do put the plus 0, it doesn't change a thing. Okay, you can see we still have the origin, but we want to go ahead and verify that point 3, negative 6. So now when I hit the little settings cog up here, now I can do the table. I cannot believe I forgot to set it equal to y earlier. All right, so we decided to check when I believe we used x equals 3. So when we have x equals 3, we for sure do get y equals 6. So let me move my graph a little bit. So when x equals 3, y equals negative 6. Okay, so we verified, hey, we have the origin. We can see that from our table of values. We have the point 0, 0. We can also verify 3, negative 6. And again, I arbitrarily picked the 3. You could pick any value for x that you wanted to, plug it into the equation, and figure out what y would have to be. Okay, so let's go back to the worksheet. All right, share. All right, so let's go back to this part A. Remember, I totally forgot to solve it for y, and I couldn't get Desmos to do what I wanted it to do. If we were to solve this equation for y, we have 4x minus 3y equals 12. We could subtract 4x from both sides. Okay, on the left, 4x minus itself is 0. 0 minus 3y is just negative 3y. That then equals negative 4x plus 12. Okay, we want to undo the multiplication of negative 3 and y. So I would divide, instead of dividing both sides by negative 3, I'm going to divide each term by negative 3. That way things simplify a little better. So negative 3 divided by itself is 1. 1 times y is y. Okay, and then 4x divided by negative 3 is 4/3 x. And then 12 divided by negative 3 is negative 4. So if I were to type in y equals 4/3 x minus 4, then I can pull up that table in Desmos. So 4/3 x minus 4. Let's go back to Desmos really quick. Okay, let's get rid of this one. We want to type in y equals. To do 4/3, you could just do 4 divided by 3. It should automatically write it as a fraction. However, you've got to be careful where you put your x. You do not want to put your x in the denominator. So you would then hit the right arrow, and it kind of puts you in front of the, or just past the 4/3. Then you can type in your x and your minus 4. All right, so we can see our intercepts are 3, 0 and 0, negative 4, which is exactly what we got when we did this by hand. But you can also hit this little settings cog, the edit list button, and pull up a table. Now, we don't have all of the values here that we have for our intercepts, okay? You can see 0, negative 4, but you can't see 3. So let's go ahead and just type in 3 down here for our X list. And there you can see that we get 3, 0. So you can see our intercepts from the table, you can see our intercepts from the graph, and if you go back to our worksheet, you can see how we found our intercepts algebraically. Okay, so there you have it. That is using intercepts to graph linear functions. Remember, using intercepts to graph is very, very exclusive to linear stuff because we only need 2 points. All right, make sure you know how to do this by hand and simply use Desmos to check your work. If you're using Desmos to do your work, you are cheating. Please understand that that would be cheating to use Desmos to explicitly do this for you. Desmos should be used just to check, okay? So in the next video, we'll talk about the slope of a line.